Okay, so I suggest that we start. Good morning, good afternoon, good evening. It gives me great pleasure to welcome you all to this edition number 10 of the networking channel, which is dedicated today to experiments in the edge to cloud continuum. So we are glad to welcome Keahey and Jason Anderson today to discuss expertly driven research in our field and the ability to build a scientific instrument for community. That's a very important topic indeed. So Kate is a scientist at Argonne National Laboratory and a senior fellow at the Computation Institute at the University of Chicago. She's well known, of course, but I would like to remind that she's one of the pioneers of infrastructure cloud computing, created the Nimbus project, recognized as the first open source infrastructure as a service implementation. She's now leading the NSF-funded Chameleon project, already created to provide a platform for data center research, which has now been extended for experiments in cloud to edge, of course, as an important support to this presentation. And she's together with Jason Anderson, DevOps lead at Chameleon Cloud. So they are going to address a very important and complex problem that our community should embrace regarding the support to discovery process, as well as providing evidence and reproducibility. So I would like to remind the assembly that you can use the Q&A to submissions that will be taken at the end of the presentation. So Kate and Jason, thank you so much for your contribution. I'm happy to hand over to you.
All right, thank you for the lovely introduction. Let me see if I can share my screen quickly. Oops. There we go. Can everybody see it?
Yeah, it's perfect.
Fantastic. All right, so thank you again for the introduction. And I'm going to talk to you today about a scientific instrument for computer science systems research. I'm going to tell you how we developed it and why. And then Jason, who, as Serge mentioned, is the DevOps lead for the Chameleon project, is going, and he's the main force behind the implementation of our edge infrastructure, is going to give you a demo of how this actually works in practice. And then I'll wrap up and tell you about some of the applications, the edge to cloud application or edge to clouds experiments that our users are running on this infrastructure. So let's start with what is a scientific instrument. And when we think about a scientific instrument, we generally speaking imagine something in domain sciences, right? So a telescope, a microscope. But what instrument do computer scientists need, right? So what science, what experiments do we run? Well, computer scientists invent new operating systems with better price performance characteristics or power performance characteristics. They invent new algorithms and networking protocols. And to experiment with these things, they need an instrument that provides innovative and diverse hardware, like bleeding edge, and that allows them to reconfigure that hardware, experiment with that hardware in as much as possible, as if it was located in their own lab, right? So reconfigure the whole stack and influence every aspect of that instrument behavior. And there's one important characteristic that all scientific instruments have, which is that they need to evolve with time. They need to evolve as the science evolves and as we think about new questions, and technology enables us to answer them, right? So if you look at these pictures, the telescopes of yonder are not the same as telescope arrays of today. And the same is true of scientific instruments for computer science research, right? So Chameleon started out as primarily a platform for cloud computing, but increasingly our users were asking us for a platform for edge to cloud experiments, right? And in this talk, I'll tell you about how that evolution happened. So first, a quick summary about what Chameleon is, right? So chameleons like to change, first of all of us know that. So this is a test bed that is deeply reconfigurable. It adapts itself to your experimental needs as much as possible, right? So you get bare metal reconfiguration. We do have a KVM cloud and perhaps more about that at the end of the talk. You can power the resources on and off, you can reboot them, you can boot from custom kernel, get serial console access, all those good things. And then in terms of hardware, we're trying to support both large scale, so computation with big compute and big data. We have 6 petabytes of storage, in all sorts of different configurations. We've got 2 supercomputing sites, or hardware in 2 supercomputing sites connected with a 100G network to now allow also experiment with large flows. But we also support a lot of diversity, right? So we've got resources that range from ARMs and FPGAs. We've got many different generations of GPUs that our users experiment with, good interesting networking hardware and so on and so forth. And we also packaged our operations model into something called Chia in a Box. Chia stands for Chameleon Infrastructure, and now other institutions are deploying that. So we've got now a new site at Northwestern that joined the original 2 Chameleon sites. We now have a new site at NCAR also that will become public at the end of November, and we've got various other institutions configuring Chia in a Box sites as well. Chameleon is a little bit different from cloud sites or cloud testbeds that came before it, in that we made a conscious choice to build on mainstream open source infrastructure called OpenStack, right? So it's mostly OpenStack, or I would say it's half-half. It's OpenStack and provides bare metal reconfiguration, and then we added many capabilities that allow you to experiment with networking in various innovative ways. We added capabilities on the front end to integrate with Jupyter notebooks and things like that. And we developed new capabilities in OpenStack to support our use case. And then finally, we invest a lot in reproducibility, repeatability, and sharing, and generally supporting experimental methodology. So we have Jupyter integration so that our users can leverage Jupyter for packaging their experiments in imperative and non-transactional ways. So the very important properties for packaging, but then also replicating. We support something called Chameleon Day Pass, which allows anybody easy access to the testbed for the purpose of reproducing experiments. We have something called Trovi, which is a trove of experiments that you can find and replay. And then we also integrated with Zenodo for publishing. And Chameleon in numbers, a few numbers here. Over our 6 years of existence, we supported over 6,000 users who worked on over 750 projects in research and education, and published more than 400 papers. And as we were supporting various experiments mainly in the cloud computing domain, we noticed that many of our users were increasingly working with IoT and edge devices, right? So we've got a blog in which every month we profile one of the experiments that our users are running. And in that blog, if you just look at just this year, you will see a very interesting experiment in biometrics, an interesting experiment in federated learning, right? So federated learning is when you can't move the data. It's distributed learning, also called distributed learning. You can't move the data and you train models when the data is, and then you aggregate those models in order to have a model that captures all of that learning. And then also in traffic fingerprinting for IoT devices, right? So you can read about those experiments in detail on our blog, but when you run those experiments on Chameleon, on data centers machines, you effectively running simulations or emulations of what you want to do, right? So that allows you to experiment with some things, but not with others, right? So if you're wondering, for example, what are the power characteristics of my new distributed learning algorithm, that's a very difficult question to answer via emulation, right? So increasingly our users were indicating that having an edge platform or extending the cloud by an edge platform would be a fantastic thing. And the goal here was captured in this: we would like realistic edge to cloud experiments from one Jupyter notebook, right? Jupyter notebooks tend to be a very interesting interface, so people are very attached to that. And as we were trying to design that testbed, there were kind of two competing viewpoints of what it should look like, right? So some people would say it should look just like the cloud, just like Chameleon that we all know and love, right? But on edge devices. And other people would say, well, that's not going to work, because edge devices, the main point is that they are connected to some IoT devices collecting data in the field, right? So location matters, just like in real estate, location matters. And secondly, yes, they are connected to all those IoT devices, to cameras, to actuators, to software-defined radios. So how are you going to handle that, right? And finally, a lot of them are not server class, right? They don't support something like IPMI, so bare metal reconfiguration is out of the question. And yet we want to be able to reconfigure those devices in some non-prescriptive ways for our experiments. So what are we going to do? So out of that sort of emerged this idea that we're going to, yes, provide a testbed that looks very much like Chameleon. The non-prescriptive access, we're going to provide as container deployment, right? We already in Chameleon, we do bare metal configuration and then we do reconfiguration via virtual machines. So now we're adding containers. We'll support the IoT devices, which we call peripherals, by building an extensible plug-in model where you can add your own camera. I mean, we're supporting currently various types of cameras and SDR and things like that, but you can extend it to add it. But then what also emerged is the users said, we would like to get out of the data center, right? So it's nice that you support some devices in the data center and we can experiment with a range of architectures, but we also have our own devices and we would like to put your SDK on those devices and add them to Chameleon, but then we don't want to share them with everybody. We only want to share those devices with my class or with my set of collaborators, and that's it, right? So in order to do that, we create an SDK that you can put on your device, add it to Chameleon, will manage users for you, will manage access for you. You're going to be able to share it within a restricted group, right? So just with your collaborators or your class, but you're going to be on the same network and on the same Jupyter notebook, in fact, as the rest of the testbed, right? So you can run experiments from your edge device to the cloud. And just a couple notational things. We've got a mailing list. If you're interested, please do join the mailing list. And we also had many people experimenting with Chameleon during the summer. And at the beginning of September, we had a fantastic workshop where our users presented about the projects that they ran on our edge testbed and shared insights on how they did that. And that has been recorded. So you can go to this webpage and you can see those recordings. There's very interesting discussions there. We will also release a report next month that came out of those discussions. So another way of looking at the testbed, so we called it Chia Edge, Chameleon infrastructure at edge, right? Another way to look at the testbed is you've got Chia Edge that runs on Chameleon-owned devices, provides some non-prescriptive ways of managing them. It runs on your devices or user devices, again, provides non-prescriptive methods of reconfiguration, but then everything on top is open for whatever users want to do for innovation, right? So you can develop new operating systems, you can experiment with security and privacy, multi-tenancy, network function virtualization, workflows, and so forth, right? And when you have a good solution that runs on the platform, you can also package that solution with the platform and turn around and give it to your users, right? So maybe you're developing some ways of data management at the edge, for example. You can combine that with the platform, give the package to your users. All right, building Chia Edge, just a little bit of eye candy. We went from machines in the data center to little installations that were built on kitchen tables under the watchful eye of Jason Scott. And what does the experimental workflow now look like? Some of you, if you have seen previous Chameleon talks, you know that I always like to talk about it in terms of an experimental workflow, where first you discover resources, then you allocate them, and then you reconfigure them. So our discovery mechanisms for the edge are very rudimentary right now. You go to the web page and it's described there. But for allocating resources, you can do everything that the main infrastructure can do, right? So you can allocate nodes, VLANs, and IPs. You can access those edge devices via advanced reservations or on demand, depending on availability. You can say, give me a Raspberry Pi, or you can say, give me this particular Raspberry Pi, right? Which is very important if that Raspberry Pi is attached to a car or a drone or some specific installation in context. And then how do you reconfigure them? Well, you deploy containers on them. We give you a catalog of images, so you're not starting from scratch for what to deploy. Then you can configure those images further, and you can snapshot them, right? So that next time you can start from this more configured container. And we provide that coveted Jupyter integration for orchestration. So our users use it to program their whole experiment, right? To allocate resources, reconfigure them, and then run in those various different edge devices. Oops, and I think this is maybe a good time for Jason to come in and give you a demo of how all of those things look in practice, how you use them.
Yeah, sure. Let me just switch over to mine now. Cool. So yeah, I wanted to basically give a little bit of a demonstration on what all of this looks like in practice. Make sure I'm looking at the right screen that's being shared. Yes. So as Kate said, all of Chameleon infrastructure supports this idea of an experimental workflow. And we have various different interfaces to the Edge testbed, and I'm going to demonstrate both the sort of the GUI interface and also the Jupyter interface that Kate talked about. But first, I thought it would be useful just to quickly show you, if you haven't really used Chameleon at all and you're interested in getting started, this is how you do it. You go to www.chameleoncloud.org, and then let me move my screen here. You can log in with federated identity, which usually is, your host institution credentials. In my case, I actually use my UChicago ID. And when you're logged in, you get a dashboard of which projects allocations you're on. In order to use Chameleon, like many other research infrastructures, you have to be a member of some sort of allocation. And if you want to have an allocation, you can apply for PI status, which lets you basically maintain and your own allocation and project, which you can request very easily through the project section. We just ask that you provide some information about how you intend to use Chameleon resources. And after that, it takes about a day, but usually allocations are reviewed and approved by then. So once you have your allocation, you can add other collaborators, etc. to them, but we're going to talk about what you can do with it. So we have a section at the top here that is launching you into all the information that we currently have about the Chia Edge platform. Notably, there is a mailing list, which you can take a look at. It's a Google group. It's free to join, and we do support questions, and a lot of people share their experiences on that list. So that's a good resource. We also have this page that shows all of the current hardware and configurations that we currently have, featuring some of those pictures that Kate showed, and also some of what we're thinking about doing with hardware in the future. And then we also finally have a whole section of documentation that basically goes over what I just talked about, and also what I'm going to show you with the graphical interface. But let's just jump into the graphical interface for now. So when you launch into here, we have single sign-on, so you should just get zipped straight through into your project. And if you're familiar with an OpenStack cloud or Chameleon in particular, this will look very familiar. It's very similar to Chameleon's existing bare metal and KVM sites. It just has a bit of a flavor of launching container isolated workloads. The main one of the main things that's interesting is, as Kate said, we support you can reserve devices for your exclusive use. This is kind of an important property, especially in computer science and edge research. You want some assurance that You can account for all of the workload that's happening on your device. Maybe you want to do some power measurements. And so it's important to have kind of exclusive access. So we do this by handling, by doing with advanced reservations. So you can find which devices may be suitable for you, find when they're available via our lease calendar, and then make a reservation for some amount of time during which you have exclusive access to that device. The other thing that this display kind of is showing currently is that, as Kate said, we have this idea of restricted devices. And what this means is if you have your own device, such as, I think there's an example here, this is actually a Raspberry Pi that's serving as part of a self-driving car platform that a researcher who works with these for education and research purposes has set up. So they actually have they built these cars, they enrolled the Raspberry Pis into the Edge platform. And because it kind of requires, they have to put the car somewhere so it goes around a track, and they have some other out-of-band steps they have to do. These devices are really only useful for their project, and so they are restricted for access. So currently I can't reserve that device because it wouldn't necessarily make sense, but they can obviously like loosen these restrictions if they want to. But just in a way that the Edge platform is kind of, it's a little bit inverting this model of where the hardware is and who owns it. In some ways, the Edge platform that we have now it's more about managing access and the life cycle of your workloads on the Edge. Anyway, that's a bit of a digression. The important part is we have this nice thing that shows you where, at what point there will be resources available. And once you have a reservation, you can then use that to as a host for your container workloads. And this really works. It has a very similar sort of interface as if you can imagine a GUI for Docker or any sort of main container runtime. So it pulls in images from Docker Hub currently. So if you publish your images there, you can use any image there. You can make your own. We also support some concept of snapshotting. So you can create a container, you can make some changes, and then you can kind of save a private copy on the Edge testbed, which can be useful if you're doing kind of iterative development. You're not really sure what outcome you're searching for yet. When you are launching the container, you have various different options, which again will look familiar if you've used a container runtime engine before. You can limit the amount of CPU available, runtime, and memory. By default, we don't actually put any limits on these, so they can take the full resources of the device they're hosted on. One interesting aspect that the testbed provides is you can actually have isolated networking between your Edge devices and containers. So you can create your own network. It'll basically be a layer 2 network, and then you can attach containers to that layer 2 network directly, like from the Edge device. That's interesting because you can kind of have some network isolation. The other interesting part, which I'll show, is the way that this is architected. You might have some questions about, well, what are the requirements of the Edge devices themselves? And actually, they don't need any inbound addressability. All that is required is they can go out. And this was sort of, by design to accommodate a wide variety of deployments of these Edge devices. So it's interesting, and I'll give a demonstration because we have various public IP addresses under the Chameleon's pool allocation, and you can actually use those public IP addresses to publicly address services exposed by your containers, even if the Edge devices themselves, like a Raspberry Pi, I actually have one in my apartment. It doesn't have an IP address, public IP address, but I can still use that as an Edge device on the testbed. So some interesting networking capabilities. We also support security groups, which allow you to keep your container network a bit more secure. Again, if you've used OpenStack, this will be kind of familiar to you. But this lets you, by default, we constrict the amount of ports that are allowed to be hit on the containers, but you can open these up if you want to expose services. So that's a little bit of a quick rundown. I wanted to actually zip over though to a different view into the interface, the Jupyter interface. And to do that, I'm going to bounce through Trovy. One second. And Kate briefly mentioned Trovy, and I need to hide my Zoom stuff so I can see it. Trovy is what we call, the trove of experiment artifacts. And functionally, these are basically Jupyter notebooks that have possibly some accompanying data, examples, and whatnot. They are a really nice tool for packaging up experiments. Also a nice tool for demonstrations, education. We've used them a lot internally to educate people about how to use our testbed features, but we also have people who have published their Edge experiments as Jupyter notebooks, and then we have a nice integration with this system into things like Zenodo, so you can actually take something that you've sort of worked on and then upload it to Zenodo and make it citable with a DOI. So just trying to sort of handle holistically the whole workflow of that. Just an example, here's an example of one that has been published using the Edge testbed, and it's an actual research project. So let me go back into this demonstration. And so when you get here, you can you sort of enact this example, this sort of experiment artifact package on the Chameleon Jupyter environment, which is what I'm going to show. So what this would do is it'll take all of the contents of that artifact and open them up into a new Jupyter notebook server that only I have access to. And the Jupyter interface is interesting because you can use it in a little bit of a different way than maybe people are normally use Jupyter notebooks. Normally they're known as like very useful tools in data analysis, crunching, visualization, but everything's just code, and we actually use these notebooks to sort of drive the Chameleon testbed infrastructure. All of our testbeds have public APIs that you can use to configure the testbed to your needs, and then we add basically some nice libraries into the Jupyter environment to make this easier, and also to let you sort of transparently use the testbed via these APIs as yourself, as your user, which you're able to accomplish through some sort of binding your session into the environment. And so I'm going to give a demonstration of a few tiny things. One is I'm just going to launch a container and demonstrate public connectivity. So we'll just try that. The first thing in this notebook, which I'm not going to show just for the purposes of time, is you can reserve devices on the testbed. You can select which ones you want and then create a list for them. And you need that list to do most of the other stuff that I'm going to show. But I'm just going to get this started while I talk about it. So one of the interfaces that we expose for the Edge testbed is obviously the ability to create a container. And these take a lot of the same arguments that you would see in the GUI. In this case, I'm just going to create a web server container, and it's going to use this image from Docker Hub. And I'm going to tell it to start up a web server just using a Python's built-in implementation on this port. And I'm going to also tell it, yes, I actually want you to expose that port because I'm going to want to reach that port from the outside. And as I mentioned, we need to provide which reservation ID so that the system knows like which, that you actually reserved resources and where to place your container. And it's been printing some updates here, and you can see it's done. And if I actually jump back over to the GUI view, I can see that, actually it created my container for me. And it's got this port, this command. So just, you can see, you can use either interface basically, but there's some nice benefits of the Python one that I'll get to. When you have the container, there's a few different things you can do with it. you can run one-off commands, which can be useful for various things. So in this case, I'm just running just checking the contents of this directory inside the container that was launched. And now I'm going to assign a public IP address to it. So I'm going to take that container and make it so I can reach it over the public internet. And so hopefully this is going to work during the demo. There we go, great. So I just reached the container's web server over this public address. And keep in mind, this container is on some edge device somewhere. I'm actually not even sure which one I reserved for this demonstration, but it's probably somewhere in the University of Chicago, or perhaps elsewhere in Rutgers. But anyway, but we now have an important part is we have a public address to it. You can also do some interesting things like you can modify the container's file system, which can be quite useful at times. So in this case, I've actually got this folder that has a HTML file that just has some content, really basic. And I'm going to upload that into my container's directory that I'm serving this web server from. And now, if I go back here, I can actually see that it has that content and it is now serving it. And this is nice because I can now have kind of a full workflow from within Jupyter where, I'm working on something, changing some inputs, and then I can rerun this to sync the contents, and then I can refresh. And you have this nice feedback loop that is possible by having access to this sort of file system abstraction in the Jupyter interface. As I mentioned, it's possible to snapshot what I just did and save it as a new container, but I'm not going to demonstrate that for the sake of time. And let's just tear that one down and move on to the next experiment. And this next one I wanted to show is a bit more complicated. We're going to use multiple containers this time, and basically going to show how you can use a notebook to attach to some experimental environment that you've created on the Edge testbed. It's demonstrating how containers can talk to each other via TCP/IP. And yeah, generally that's the point of this one. So I'm going to be using a lot of the same stuff that I just showed, but there's a few new things that we're doing. So I'm going to just get this started. So now I'm going to, the experiment basically it launches two containers. One of them serves as just a kind of a message buffer, message queue, and it's just able to accept messages and then send them back out to consumers. In this experiment, the Jupyter Notebook is going to be consuming messages from this central thing. Then we're going to start another container that is pushing messages into there. And these containers could be on the same edge device. They could be on completely different edge devices because of the sort of networking capabilities that we've built into the testbed, where all the containers on the edge devices can address each other over private networks. So this one, we're doing a lot of the same stuff. I'm saying I want to launch this mosquito image, which is a implementation of this message broker, which is a public image. It requires a few different ports to be exposed, but same story there. The new thing is that you can actually pass in files that are going to be mounted to the container at runtime. If you haven't used containers much before, this is a really common pattern for configuration. So it's kind of an important property to have in an edge testbed that uses containers. Reason being, it's quite arduous if you have little changes that you're making to a container that can be expressed as a configuration file. It's annoying to have to keep copying that file into a container, save a new image, push it every time. And so a lot of container images have a pattern where they have a general implementation of something, and then you sort of parameterize it by putting a certain configuration file in a well-known location inside of the container image. And many containers work this way. And so the Edge testbed can support this. In this case, again, I have, this is an interesting property of the Jupyter interface, is that I can have these such files, configuration files, stored here in my Jupyter workspace. In this case, I have a configuration for that Mosquito service. And I'm just going to take the contents of that file and pass it in and tell it to put it here inside the container where it's expecting it. Okay. And lastly, I'm not going to give, actually, I'm going to give this one a public IP address, but I'm actually going to communicate. I'm going to be sending it messages from another container over this private address. So I'm going to take this address and store it because I'm going to need it later. All right, now jumping into the other part of this experiment. So we just did this. We created this guy. And now we're going to create this one, the publisher. So I'm going to, again, start that going. So the publisher is the thing that's just basically generating some junk messages and pushing them out into the central one. And we're going to then attach to that central one and start read them. So we're basically going to be displaying information as it's coming in from the outside. Oops, what happened here? Oh, yes. Let me just do some cleanup from when I was preparing for this. Cool. And so this is broadly the same type of thing that we're doing with the message broker server. There are two differences, and maybe I can start this now. The main difference is that we're also able to customize the container's environment. So you can pass any environment variables here. And here, this is nice because I'm going to tell it, oh, when you're going to be sending messages, send it to a host over this private IP, which was the one that printed out here. This is just another nice way that the Jupyter interface can help, because you don't really know what this IP is necessarily going to be ahead of time. It might be something that is randomly picked, but now I can just put it into a variable, and my notebook now kind of always will work. I don't need to have any hard-coded values here. Just sort of a benefit of using a programming language to program your experiment. Lastly, I am overriding the default command. Most containers come with some sort of default command. In this case, I actually want to instead run this little script that uses a binary inside the container and publishes messages to that host that I set up. In this case, I'm actually just generating some little randomy numbers and just publishing those. In the meantime, that has finished. And so now for the last step, we're going to connect this Jupyter server to the central broker. So we are here. We're going to go over the internet, connect to this one, and then start pulling messages that were published from here. Okay, so we have that address. I'm just going to use like a Python library for connecting to such a message broker. And I think that said it's done. And as the last step, now I'm going to use some other nice libraries that you can use in Jupyter. They have tons of visualization libraries. One of the benefits of using such an environment, but also they have this nice progress plot, so I can actually see live data coming in. It's being published from my publisher container. So I'm just polling, getting messages as they're coming in, pulling them from the Edge computing environment. So this is kind of a little bit of a toy example, but I think it demonstrates a lot of the current capabilities that the Edge testbed has. One thing that I don't really have time to demonstrate now is we do have integration with various cameras. In particular, we have some Raspberry Pi cameras and generic just video driver cameras that we have connected to some Edge devices. We just added support for GPIO, and we also have Jetson Nanos, which you can use the GPUs on them as well. So we're trying to make the Edge testbed really take advantage of the fact that there are lots of different ways that you could be configuring these Edge devices, interesting peripherals, interesting places. And so trying to make sure that we can accommodate as much of that as possible. I should probably stop at this point before we go too far over and hand it back to Kate for some remarks about how people have used the testbed and closing thoughts.
Okay, thanks, Jason. I hope that the screen is shareable now, and we are at a point where this slide now has a lot more sense. So, by the way, all the demos that Jason was showing, we've got Jupyter notebooks for those in our Trovi repository. So, if you want, after this presentation, you can go, or even during, you can go and rerun them. But here are just a few examples of what our users have been doing on the Chia Edge testbed. And the first example comes from Rick Anderson, who is the director of virtual worlds at Rutgers University. And he runs wonderful classes where he introduces young people to machine learning by letting them program self-driving cars. So the self-driving cars, you see a picture of the car on the right there. They are all connected. They are equipped with a Raspberry Pi. And now when you organize a car, when you organize a class and you have a fleet of those cars and you need to assign them all to a student and then have the student drive them around this track that you see the picture on the bottom. So the cars are supposed to drive around the track and not collide with the cones and each other and wander off and things like that, right? So you need to build machine learning models that allow them to do that. But when you're trying to assign those cars to the participants in the class, that actually turns out to be a logistically complicated activity because the Raspberry Pi gets on the network, you don't know which one that is, which one corresponds to which car and so forth. So they decided to use Chia Edge to add the Raspberry Pis on the cars using our SDK to the testbed and make them available for this restricted sharing, right? So restricted sharing just with the class. And then of course, once you do that, the device not only becomes shareable, so the students can make advanced reservations on those Raspberry Pis, but also they can access them via the Jupyter Notebook, right? So via Jupyter Notebook, they can program their application from the edge to the cloud, right? And for the cloud, they can put their results in the cloud, they can store the data, they can train models, and so on and so forth. So a very interesting educational application, and we hope that eventually, again, the Jupyter notebooks and all the materials that would allow you to do a similar class yourself will be available via Trovi. So here's now another example, and an example of what might happen to those cars when they grow up, right? When they grow up, they could become self-driving vehicles in precision agriculture. And so in particular, on the bottom there, you see a picture of agricultural robot in a cornfield. That robot has multiple cameras, equipped with multiple cameras, drives around the field and looks at the plants, right? That's called phenotyping, which is reasoning on the state of the plants based on their physical appearance. And then, you can decide if they need more watering or more fertilizing or things like that, right? And there are similar applications with livestock and so forth. And all of that is very promising, but there is one missing ingredient. And that missing ingredient is cost-effective wireless for rural communities. And this is a huge challenge. And this is a challenge that a project called ARA, which is a new power project, just recently got funded, is well positioned to solve, right? So make the rural broadband as affordable as urban broadband. And they work on a range of very challenging problems. They work with us, decided to use Chia Edge for their infrastructure, but of course they're going to create a separate test bed. So we're putting that Chia Edge in a box for them. But then they also said, what we would like to do is we would like to do spectrum reservations, right? Because it's very important for them to subdivide the ability to subdivide the spectrum, wireless spectrum. So they will be also extending Chia Edge in order to provide that capability. So here's another quick example. This is a project from the Florida International University, and this is a collaboration between marine biologists, robotics scientists, and the student who coded up this whole infrastructure. So you've got a group of scientists who are interested in mapping fish populations and understanding better how factors like pollutions, for example, play into changing habits and habitats of those populations. So what they do is they have a range of, autonomous vehicles. Those autonomous vehicles are equipped with various edge devices. You see those vehicles in that picture on the bottom there, and they follow those fish populations. And as they follow them, it's important for them to decide, which way to go, what fish they are seeing, and so on and so forth. And they were preparing to code up this project, and they started talking to us, and they were exploring configurations of edge devices that are connected or ultimately will be connected to those autonomous vehicles, sending data to the cloud, processing in the cloud, sending results back. Then ultimately, based on their experimentation, our edge testbed decided to equip their autonomous vehicles with a specific type of device. And actually, there was a little, as Jason was giving his presentation, he gave a little flash of their Jupyter notebook, which has already been packaged and made available via Trovi. So if you have a similar problem, right, you want to explore edge to cloud interactions versus something that can be done on just the edge device, you could look at what they did, or even clone that Jupyter notebook and modify it to apply to your use case. And then last but not least, here's an example from a Flynet project. This is a CC Star NSF-funded project, and they explore technology that is critical for low latency applications, right? In particular, they're focusing on drone video analytics that then allow you to do route planning for those drones, right? So in the picture on the bottom, you see you've got those purple lines. Those are the flight plans for the drones, and you can see that you don't go. And then this green mass of stuff that's weather, essentially. That's the moving front. You can see that you don't go just in a straight line from point A to point B, but you go around that bad weather. You fly the drone around that bad weather, but then that bad weather can change, right? That clouds and other phenomena can move, and you may need to do some replanning of that route. So they use the Chia Edge testbed for obviously edge computing experiments. They leverage the reproducibility capabilities of Chameleon, but they also would like the scientists from that previous slide, to make the results of their research or make the experiments from their research available to others, which is particularly important. So I mentioned earlier we had the workshop in September where users were exchanging various experiences. What we saw is a huge both willingness and desire to share, to build on experiments performed by others, because there just isn't a lot available in this area yet. It's a new emergent area, and people would love to build on each other's experiments and sort of get the leg up, right, a little bit, get faster towards their research. Okay, and just a few parting thoughts so that we get a few minutes for discussion, hopefully. Like I said, scientific instruments are constantly in motion, right? You are sort of laying down the pavement as science walks on it. And since people are constantly thinking about new scientific questions to answer, you constantly have to build for them. There's another thing, an insight I wanted to share with you that came from analyzing the data from the workshop we did in September. And that is that we've got an interesting inversion of what it means to run a testbed, right? So when we were starting out with Chameleon and we were building a testbed essentially for cloud computing, the conventional wisdom was that a testbed is essentially a pile of very interesting and usually very expensive hardware, right? So some of the nodes we were buying are, $40K, $50K dollars. They have many GPUs on them. They have Optane memory. They are configured in various expensive ways. It makes sense to put them in the test bed where the cost is amortized over multiple uses and also democratizes the use of those expensive resources, right? So you don't have to work for a supercomputing center to have access to them. So this is how we used to think about test beds, access to a lot of expensive resources. Now users are telling us resources are not the thing. We have the resources, we have the hardware, and we have quite a bit of it because it's inexpensive. And the interesting thing is where we put the hardware, right? Now, what we want from you, what we want from the testbed operators is interesting ways and reliable ways and secure ways of sharing this hardware with our collaborators or with our class, right? Restricted sharing. But also, we want to connect this hardware to some residual set of resources in the testbed, right? So originally, it was provider-owned expensive hardware. Now it's user-owned, inexpensive hardware, but also hardware that needs now to be shared in secure, reliable, and agreed upon ways, and non-prescriptive ways, because we're still talking about computer science experimentation. So the definition of a testbed is moving out of the data center, and it's moving increasingly into being a sharing method and connecting mechanism, right? Plus some residual resources. Another thing that we realized that people want to share things in different ways. And again, when we were starting out with Chameleon, the conventional wisdom was that resources need to be reconfigurable on a bare metal level, right? And that was a one size fit all, right? So the conventional wisdom was, let's make everything bare metal reconfigurable because you may not need that feature, but maybe you will, and you might as well have it. Now we're increasingly realizing that bare metal reconfigurability has a cost, right? And this one size fit all is not necessarily a good thing for all experiments, right? So I mentioned earlier, we have a bare metal testbed, that's most of Chameleon, but we also have a KVM cloud because it allows us to subdivide all the cores on the resources more efficiently, right? So when we started out Chameleon, we were buying nodes that had 24 cores, and we thought, oh, that's a lot of cores. Let's allow some users run virtual machines. Now we're buying nodes that have 128 cores, right? So allocations on bare metal level of expensive resources like that means we're getting increasingly expensive, increasingly more cost per experiment. Furthermore, resources like edge computing, it makes it very difficult for them to support bare metal configuration. You could, but you would need a very special carrier board to provide the equivalent of IPMI, essentially, in order to provide bare metal configuration. And that, of course, costs not only money, but it also costs power. And as we're moving increasingly towards supporting IoT and supporting computing at the edge, in conditions that perhaps don't have a lot of access to power, right? That where perhaps you're running on solar batteries and it's an installation that's supposed to last 10 to 20 years, bare metal reconfiguration becomes increasingly costly, and there's an increased awareness of that. So what we're seeing in demand for experimental capabilities is moving towards a spectrum of various reconfigurability mechanisms. And then last but not least, but something that I always like to emphasize is, especially in an emergent area where in a sense we're starting from scratch, it's good to form good habits and in as much as possible share research in digital forms, right? So share experiments and data and software that was used to obtain a result, and not just the papers that describe the result. So as the rate of progress accelerates, we can no longer afford to ignore those digital artifacts. So that's my call to action for today, is pay attention to how you share your research. And now I think hopefully we still have just a few minutes for questions.
Well, thanks a lot, Kate and Jason, for sharing with us this very rich presentation and experience, showing that the community is maturing and that we are more and more knowledgeable with respect to building this scientific instrument, like in other domains. Let me hand over maybe to questions. Let's see if there are a few questions from the audience. Please, you can use the Q&A. You can open your mic in case. Whilst we're waiting for questions, maybe, so you touched base about the data, which is of course quite important. So do you have any policy with respect to sharing data on Chameleon?
We don't have policies on Chameleon specifically because it's the user's experiments that produce data, not Chameleon itself, right? So we don't have, I should qualify that, we don't have policies for user experimental data. We expect that specific institutions will cover that. We, of course, share data from Chameleon, from the operations of Chameleon. So if you go to www.scienceclouds.org, you know, there is a tab for traces, and you can see anonymized data from the testbed, right? So the policy mainly is anonymized data so that you know, you can't tie specific activities to specific users or experiments, but you can still use the data to reason about the operations of the testbed.
Good, thanks. I don't see yet another question, but so let me ask another one. So it's interesting, of course, to see, and I welcome this, that you have been moving from cloud to edge, and some others have been moving from, let's say, edge to cloud.
No, yes.
Where are we going to meet, and how do you think that we could work with respect to this important potential? You gave, for instance, an example where some of the experimenters were using Chameleon, but they were also needed some other type of resources. So how do you see this?
Yeah, I think that the future is going to be very flexible. And like, as I tried to say at the last slide, I think that testbeds will become environments where you can find some resources. But because context, the deployment context is so important in Edge, I think that users will increasingly be operating their own Edge devices, but will come to the testbed for the sharing methods, right? So we'll come, I mentioned we have this SDK which is something that you can install on your device and add it to the testbed. I think that mode of configuration will become increasingly common, where people will want to add their devices to the testbed in some way. The big questions in that space are, you know, how do we do it cost effectively? I think that if we can find reconfiguration methods that are not power hungry, that are very thin, very efficient, I think that that's going to be something in demand, because again, those devices are going to be deployed in the field. And if we're talking about, let's say, a class, well, that's easy. If we're talking about deployment in the city, that's easy. But if you go out and you know, do land management or deployment, like as I was talking to you with the ERA project and also with the FIU project, you know, those are deployments that might not have handy access to a steady power supply. Right, so managing those concerns will become of increasing importance.
Well, thanks a lot again for taking the time and sharing this with us. For the audience, you know that you can replay. We have this YouTube channel that has been advertised. You can always also share questions in case you would like either Kate or Jason to continue the discussion. And we, of course, will welcome you for the edition number 11 in 2 weeks from now. As you can see, it's going to touch base on a different topic. If you enjoy watching your favorite movie, then you will see how Netflix do manage this process. This will be a day in the life of Netflix streaming, a conversation about Netflix adaptive streaming and more, with T1 and Renata Teixeira. This will be chaired by Jean Kurosi. And we, of course, ask you to register to the event as usual. and looking forward to seeing you in 2 weeks from now. Thanks a lot. Thanks again, Kate and Jason, and looking forward on the networking channel again. Bye-bye.
Thanks, bye.